Good evening, my 12th standard warriors, to the fifth session of electromagnetic induction, where we are going to talk about the growth and the decay of current in a LR circuit. And we are going to see the significance of that, including the time constant. And then we are slowly going to move towards the oscillations in electrical circuits, basically the LC oscillation. Alright, so get ready guys for the long-term batch, which is the Pathfinder series for all the 12th standard students out there. So welcome aboard J. Srinivas, Zayed, Balaji, hello Samuel, Ames, Delhi, Thamilian, hello Renu, hello everyone, hello 1, 2, 3 ABC. Welcome aboard, welcome aboard. Do let me know if you can see me and hear me loud and clear. Hello Kitia, hello Tanmay. So I'm Shreyas, I'm the physics master teacher at Vedantu. I not only teach on the Enthuse channel, but I also teach on the regular paid platform of Vedantu. And you can find a lot of my micro courses out there. So if you're already in the subscription, you would have seen me somewhere or the other. Alright, and I have been teaching for a very long time, so many of you probably don't know me. So I'm managing the physics department at Vedantu, and in this period of my teaching career, when I started my journey almost like a decade back, I really enjoyed physics. I had got almost full marks in physics when I wrote my JEE, and when I started teaching, I saw that many of my kids are getting amazing marks, and many of them got 2-digit all India ranks in JEE. And that's when I started devoting my entire time towards teaching. And I'm so glad that many of my students are not just a part of the prestigious institutes, but they have even graduated and now they are doing really well in life. And over this period, I think many of my students, like 100, 200 at least students, have got really amazing ranks, and lots of students have got into, if you count all the NITs, BITS, and all the other IITs as well. So I really hope that this lecture series on YouTube is going to make a difference in your lives. And if you want to know more about me, you can follow me on my Instagram handle. So it's a good time to also check the schedule for this week. So like you can see over here, is this a new playlist? No, this is not a new playlist, just the thumbnail has been redesigned, okay? So this is the fifth session, and if you have missed any of the previous sessions, you can definitely check it out. But today we are doing the LR circuits and LC oscillation. Basic theory wise, the chapter will be over. So you're going to have a Menti quiz on Friday evening. Notice most of my lectures will be at 7:30 in the evening. And if there is a morning class, it will be usually at 9 o'clock in the morning. Alright. And if you want to attend 11th standard classes, well, you can do that. That's friction and Menti quiz again. So if you have your juniors who want to study in English medium, please let them know about Enthuse. Alright. And a special session, I'm planning to conduct a session for all the 2022 aspirants who want to probably clear their backlogs and want to make a strategy for the next year. So get ready guys, I'm planning to conduct a session for all of you. Okay, so after this session we are going to have an advanced session also. Yes Zayed, there are Menti quizzes twice in the schedule, but they are for different people. Like this one, the white one is for 12th standard, the red one is for 11th standard. So don't get confused. Okay, cool. Ankit, bacha, kya ho gaya? Why are you frustrated? Chill man, come on, join in. Watch the lecture enthusiastically, and whatever problems, troubles you have, do let me know on probably the chat, or after the session is over. We'll see what we can do best, and we'll try to help you out. Okay, PL, I am fine, bacha. Probably I did not shave from last 2 days. That's why probably it looks as if I'm tired. Plus, looks like I need a haircut. All right, chalo. Before we go ahead, let me also flood the screen with our results. Because, come on, it's time that Vedantu also boasts about the results. And rightly so. I mean, we are proud to actually talk about this. Because just in JEE Main's second attempt, which happened in March, 1 in 2 students had already qualified, for JEE Advance. And there were like, around 1500 students who had got above 90 percentile. But these numbers have improved even more. You can see that 4 out of 5 students are now qualified for JEE Advanced by now after the third attempt. And look at this, guys, there are almost like, okay, this number is not there, but I remember it's around 3,000 students have got about 90 percentile. That's crazy, and so many of them have got even 99 plus, 99.9 plus percentile. That's 27 students from Vedantu alone. And how can we not forget Vaibhav Bajaj, who is from Punjab? He got 100 percentile in maths and chemistry. He has also qualified so many Olympiads, and these are all long-term Vedantu students. So you should be proud that you are attending the Vedantu classes out here. Your chances of getting into JEE, cracking the JEE examination improves drastically the moment you become a Vedantu student, and the same results, very similar, very outstanding results again in ICSE as well. So these are all the achievements, and like you can see over here, drastic improvement from the first to second to the third attempt, almost like 7.5 times the growth if you compare to the first. I'm pretty sure in the fourth attempt, which is going to happen this month, you are going to see even more better results than this, and that's what makes me feel really proud. And that's why I confidently tell you guys, join the Vedantu Pro subscription course. Trust me, everything is there, be it KVPY, be it JEE Mains, be it JEE Advanced, be it Olympiads, be it boards, all your needs are taken care of. Even your test series, your notes, your material for solving, your doubt solving, everything is there as a part of the Pro subscription course. There is a batch which just started on 9th of August. You can even join that, and if you want, you can join the 6th September batch as well. There are different packages available as low as 3,000 rupees per month when you use the coupon code SHHPRO, where you get 10% off. So definitely you should consider this. I'll talk more about it towards the end. Now let's talk about the discharging and the charging of an inductor, and let's get ready, guys. And by the way, in case you have forgotten to subscribe to our channel, please hit the subscribe button now. And before we begin, a small token of your love, go smash the like button down there. Alright, Kavita, I'm very good. Tanmay, KVPY is a part of the Pro subscription, bacha. Okay. Hi Alina, good evening. Wow, Deep Laha, you're attending the lecture of English channel for the first time. That's really good. Hi Ria. Even I became focused for a moment that it is Shreyas or Shahrukh. Oh my God, Shahrukh is my favorite, the unknown. All right, I feel very happy. Okay. Yes, Katishran, you can change your branch after the first year of IIT and NIT, but it is very difficult. Do not look forward for it so easily. Do not keep it as an option. Like, don't think that it will happen. There is a very slim chance that it can happen. All right. Now, why are we talking about charging and discharging of an inductor? See, what was inductor? I have told you. Inductor is nothing but, it's a device which produces electrical inertia, and it basically will resist any change in the current. So if the current is flowing, it will be fine, but the moment there will be changes in current, it will produce an EMF, and that induced EMF we have all seen is negative L di by dt. That minus sign stands for the resistance, like it opposes any kind of change. If the current increases, EMF will oppose it. If the current decreases, then minus and minus will become plus, and the EMF will help it. And if the current does not change, that means di by dt is 0, then you will see the EMF is also 0. Now just imagine this. This is a resistor, okay, and maybe there was current flowing in it. Maybe there was a battery. Okay, maybe there was a battery. There was current flowing in it. Now I remove the battery and then I connect the wires. Now the thing is, what will happen to the current? Why will, or rather, will the current change rapidly or will it change slowly? That's what you should figure out. See, if there was no inductor, if there was no inductance, there will be no inertia, there will be no resistance to the change in the current, and things will happen instantly. Like if there was current flowing and you remove the battery, that's it, the current will vanish off instantly because there is no resistance to change. But the problem is there is an inductor. Inductor will be like, hey, wait a minute, the current flowing in the circuit was, let's say, 10 amperes. You cannot go to 0 amperes so fast. Wait for it. You have to wait your turn. So it'll be like, okay, I'm going to oppose the change and I'm going to create this EMF. So it's going to oppose that decrease. It's going to resist that change by creating a back EMF. Okay, and the current, instead of dropping suddenly, you are going to see a slow change. All those of you are joining in late, it's okay, just join in. I've just started. You can go back a little bit, maybe 5 minutes, and catch up at 2x speed. Okay, you can do that. So what just happened? If there was current flowing in an inductor and resistive circuit, the current does not die out instantly. Why? Because that current's decrease is opposed by the inductor. It will create a back EMF, induced EMF. It will say the current cannot die down so easily. It will help it, and the current will take a long time to actually become zero. We are going to find out the equation, we are going to draw the graph, and we are going to see all the other things associated with it. Okay, chalo, let's get going. Hello Sholindra, hello Satvika, hello Lalita, I'm very good. Hi Kritika. Hello, welcome aboard. Hi Sriniti. Hello everyone. Remo, welcome. I'm very good. Okay, so let's begin guys and let's start writing the equations, and if you are new, do not forget to hit the subscribe button down there. So t is equal to 0 refers to that time, okay, refers to that time when the current just starts to decay as in it goes down, it vanishes slowly, it decays just when you close the switch, and the current which is there, okay, maybe the current was flowing like this, okay, the current was, let's say, I0, it will slowly start to decay. This is at some time, at some instant during that decay, during the decay. So the current won't be I0, it will be some I, okay, it will be some value of I, which we are going to figure out in a bit. Eventually, after a long time, this is after a long time, we will see what happens to the current. We are going to see that. It's not that difficult to see what that current will be. Okay, let's try this out mathematically. Now, here is what I'm going to do. At some instant, let's apply Kirchhoff's voltage law across the loop. At some random instant, how will the KVL equation look like? Well, there are only two devices, so I will have only two terms in the KVL equation, in the LHS and on the RHS. Remember, the sum of all the voltages across the loop in a circuit is always 0. So that's what we are going to use. Now, let's say I start from here. I will encounter a drop of IR. So I'll encounter a drop, that's why minus I into R across the resistor. And we all know what is the voltage drop across an inductor. And what is it? I've just told you. It is minus L di by dt. This will be equal to 0. So start from here, go across the resistor minus IR, and go across the inductor minus L di by dt. You come back at the same point, so the sum of all the voltages will be 0. Everybody fine? Now just rearrange this. Let's see what do we get. So minus L di by dt will be equal to IR. Cool? Okay, let's rearrange this a little bit. You might be wondering, why am I interested in rearranging this? Guys, do you see di and dt? Probably I need to integrate to get some function. So that's why I'm trying to get it in a beautiful form which looks like integrable. Okay, so let's try this out. Probably I will shift I with this di. I do not like this constant. I will shift all the constants on one side. dt is something not related to I, so I will shift dt on the other side. So this will look like this. di by I is equal to that minus sign taken over here, R over here, L below, and dt on this side. Cool. Now I think I can integrate this. I'll put an integral symbol here as well as here. Now the reason why I have put all these numbers outside the integral is because all these numbers are constant. Okay. Now let's think about the limits of integration. So to check the limits of integration, here is what we need to do. See, at time 0 the current was already established and it was already present and it was given to be I naught. So when the time was 0, the current was I naught. When the time was 0, the current was already I naught. But after some time t, the current is I. So at some time t, the current is I. So those become the corresponding limits. So always it should be corresponding. So when time is 0, what's the current? When time is t, what should be the current? So just put it like that. Okay, so let's try this out. First of all, what is integral of dx by x? It is ln x. It goes to log. Yes, it is log. Correct? So let's try this out and see what do we get. We'll get ln I, but substitute I as I and then also substitute I as I naught and then subtract it. So you have to substitute the limits. Do not forget that. So I as I and then I as I naught. Okay, is equal to minus R by L. Integral dt is t. Substitute t as t and substitute t as 0 and then subtract them. Okay. So this is the log a minus log b. Log a minus log b is log a by b. So this is how it will look like, minus RT by L. Fair enough. Now I know what to do next. I will just erase this because I don't think I need it anymore. So I'm just going to erase this as well as probably even this. This is logarithmic form. Let's convert it into exponential form. Let's convert it into exponential form. Surendra Shure, you can see my name below. My name is Shreyas anyways. Okay, so convert it into exponential form. I by I naught will be e raised to minus RT by L. That's the definition of logarithms. Log of x to the base e. If it is y, then e raised to y is x. That's how it is. Cool. So rearrange it little bit more. Just shift the I naught there. And what am I going to get? I will get I is equal to I naught e to the power minus RT by L. So hence, that's my final equation which I wanted. That's it. I is I naught e to the power minus RT by L. This gives me general function of current as a function of time. You tell me time, I'll give you the current. Well, if you don't believe me, I'll just show that to you. Okay, I don't need this anymore. I'm just going to erase this. Okay, now observe. Let's substitute. T is equal to 0. Substitute t is equal to 0. It will become e raised to minus 0. E raised to minus 0 is 1. So therefore, I will be equal to I naught. Fair enough. At time 0, current will be initial current. Okay. Put time as infinity. Put time as infinity. So this e raised to, the time is infinity. Now e raised to minus infinity is as good as e raised to infinity in the denominator. This my negative power will come below. This is nothing but 0 because this will be a very large number. Okay, in case you don't believe it, this is like this, which is nothing but 0. So what will the current become? If this number becomes 0, this current will also become 0. That means after a long time, the current in the circuit will vanish off. So after a long time, the current will not vanish instantly. It takes a long time for the current to vanish. That's the job of the inductor. If the inductor was not there, the moment you turn on the circuit, you will see the current will go to 0 instantly because there is no resistance to change. I hope this is clear. Mutual induction circuit problems are there, bacha Jai. In fact, I have given some questions last lecture. Plus, I'll be doing some more questions on mutual inductance in the advanced session, and you'll also see it in the Menti quiz Jai. Okay, so you can check those out. Also, check the Tattva material. You will see the mutual inductance problems. Yeah, so finding mutual inductance and other things, basic things are there, but not too complicated. And yes, you will also see transformers, but that will be a part of AC circuit. Okay. Very good, Ria. Glad that the screen is clear. Thank you, Wizard. Okay, enough for AIR1. For AIR1, there are a lot of things which are needed, bacha. Nothing is enough. The sky is the limit. No matter what you do, might not be enough. So it's all based on many factors, but yes, Irodo is must, but not sufficient, is what I would say. Yes. Okay, cool. Chalo, let's get going. So remember this equation, all right? And by the way, I'll also give you the derivation of this on the slides, which is ahead. Okay, so the derivation will be posted here. So later on, you can see it. Now, the interesting part about that current will be, see, look at this. There is, initially, there will be current. Okay, let's forget this graph. Look at this. There is current, and that current dies off exponentially as it decays. Not this one, the other graph. Look at the other graph. Okay, so you can see that. Okay, it was there at some time. Okay, so I'll just write down the equation. I is equal to I naught e to the power minus RT by L. You can see clearly that the current starts from a number and it becomes 0 after a long time. It starts with I naught and it tends towards 0 after time tends to infinity. So this is the current versus time graph, which is also called as exponential decay. Exponential decay. Why exponential? Because there is a function e raised to something. E raised to something is an exponential function, and because it is decreasing, that's why it is called exponential decay. Okay, what happens if there is no resistor? Well, if there is no resistor, there will be no decay because the inductor will always store that energy. So there will be no decay of current. Remember, resistor is the evil guy. Resistor is the guy which loses heat, loses that energy in the form of heat. So if there was no resistor, there was no chance that energy will be lost. And the current will continuously flow, and that would be an ideal circuit. Alright, now there are some interesting numbers that I can substitute. Make the upper power, e raised to that power, as -1, or basically the modulus of that as 1. How can I do that? Suppose I make time as L by R. Suppose I make the value of time as L by R. So I am going to get current is equal to I naught e to the power minus R by L into that time as L by R. So this will be nothing but I naught e raised to -1. What is this? This is I naught 1 by E. Now if you remember this from capacitors, I have already suggested you to remember the value of 1 by E. E is 2.71, but 1 by E is nothing but 0.37. You are supposed to remember this value. Always keep this in mind. 1 by, very, very important. So what am I going to get? I will get the current is nothing but 0.37 I naught. That means it is 37% of initial current. 37% of initial current. After how much time? After a time of L by R. This time has been given a symbol, and let me write it down. This is called as tau, which is nothing but the time constant. Time constant, a very, very important number for all of you. After one time constant, which is L by R, the current will reach 37% of the original current. That means if one were to draw the time constant, let's say here, this was the time constant. If you mark the number over here, this will be 37% of I naught. So 63% would have vanished, 37% would remain. After 2 time constants, even less would remain. After 3-4 time constants, the current will vanish and it will be hardly there. So after maybe 5-6 time constants, you will hardly see any current left over there. So this time constant gives us a sense of how quick the decay is. If the time constant is large, that means it takes a long time for it to reach 37%. So it decays slowly. And if the time constant is less, that means the circuit decays very quickly and there is very fast decay of current in the circuit. So that's something which you should know. Very good. Hi Chitra. Growth, I am coming to that, the unknown. Kavita says clear. Very good, Ria. Understood though. Excellent. Polarization is important, bacha. Everything is important. Family, if you are a 12th standard student, remember there is nothing like important or not important or less weightage topic. Everything is important. Only for the current students we give strategies for important, not important, because many of them have not probably were not very clear about how to study, or probably did not get the right guidance at the right time, or due to some reason they had a lot of backlogs. So that's when you have to only study a limited topics, because you cannot do everything in the last moment. But you guys have time, so you cannot leave any topic. If you start doing that, or if some coaching is telling you this is important, this is important, this is not important, then they are not guiding you rightly, they are fooling you. Please do not do that. Okay, chalo, let's get going to the next one. Okay, I studied mechanical engineering, bacha. So all the things are there over here. Okay, now let's talk about the growth of the current in an inductor. Okay, let's talk about it. Hello Suchita. Okay, very good, Arpita. Okay, clear. Chalo, let's get going to the growth of current or charging of an inductor. Obviously, if the current has to decay, you have to charge it. So only when you charge it will the current decay. So let's get to the charging part. The things are very similar. Okay, it's just like capacitors. How many of you remember the capacitors? RC charging and RC discharging. RC discharging, RC charging. Do you remember? We have conducted the classes right here on this channel in the Pathfinder series. Thank you, family Badrinath. Next class, Giri, will come up probably very soon. I'll let you know. Yeah, you remember? Do you remember the formulas were also very similar? In discharging, if it was e raised to minus something, in charging it was 1 minus e raised to minus something. That was the only change, and that's exactly what happens. Let's discuss. See, when t is equal to 0, that means, I'll just put it over here, you have connected a battery across L and R. Battery is just connected across L and R. So if you just connected it, probably the current, I don't know, will be something. I will just put it as I naught. I will figure out what is I naught later on. After some time, this is at some time instant. This is at some time instant. The current in the circuit will be just I, and this will be after a long time. Sometimes it is also called as the steady state. This is also called as the steady state, just like you had in capacitors. Okay, so this is also called as the steady state. So I will call it as I infinity. Okay, I'm just trying to figure out what these values will be. Now, just by logic, you can get this, guys. This current will be, believe me, I naught, instead of e to the power something, it will be 1 minus e to the power minus RT by L. How do you get this? You will get it again via KVL and integration. Thank you, Kavita. Okay, Praveen, I don't know much of Telugu, bacha, but I'm speaking English. I think that should be sufficient for now. Ram Kailash, you can leave comments after the session ends. I'll definitely help you out with whatever advices you need. Okay, cool. So now here is the thing. This equation helps me understand how will the current grow with time. How does the current grow with time, right from 0 to infinity? Let's try out some special values and see what do we get. Okay, let's say the time value is 0. If time is 0, then e raised to minus 0 will be 1. Now 1 minus 1, 0. So what will be the current? It will be 0. So the moment you connect the circuit, the current will be 0. That means the inductor behaves or acts like an open switch. It blocks the current. So when just connected, it acts like an open switch initially. Okay, it blocks. It will be like, see, all this while there was no current. Suddenly you turn on the switch, inductor will be like, hey, wait a minute, hold on. You can grow, but wait a minute. It takes some time to react. It will like, first wait. So the current won't rise instantly, it will be zero. It will start from zero. Make sense? Okay. Similarly, think this way. When time tends to infinity, then e raised to minus infinity will be 1 by e raised to infinity, which is 1 by infinity, which is nothing but 0. So this term will become 0. This term will become 0. Correct, guys? That means the current will reach a steady value. That means, therefore, the current will reach a steady value of I naught, and it will become constant. It will become constant. The current will remain constant in the circuit. Is everybody getting this, my warriors? All my warriors understanding this? E raised to minus infinity, because time is infinite after a long time, that is. So e raised to minus infinity will be a very small number because denominator will become very huge. So the current, because this term becomes 0, the current will become I naught itself. Now here is the thing. If the current becomes constant, what will be the voltage across the inductor? Quickly answer this question in the chat box. If current is constant, what is the voltage across the inductor? Quickly answer this in the chat box. This is very easy. You should be able to get this. What would be the voltage across the inductor? I is constant. I is I naught. Try to recollect. EMF, back EMF developed in an inductor is L di by dt. So it will be 0. So the voltage developed across the inductor will become 0. That means it will be acting like a closed switch. So it acts like a wire. Very, very important statement. The inductor behaves like a wire. No voltage across it. It's like a wire. What is the voltage difference? 0. So what will be this current? Current will be voltage by resistance. What is voltage? E. What is R? R. So this current undoubtedly will be nothing but E by R. So I can probably put it here as well. Okay. So this will be nothing but E by R, because this inductor behaves like a wire. Very, very important statement. Very good, Sinchana, Riya, Kritika, Dravid, excellente family, Badrinath, Jayasri, Uba, Balaji. Very good, very good, very good. Very good, Nidhi. Excellente. Now I can probably also write this equation instead of writing as I naught. I can also put this as E by R, and then this probably should become your equation, which you must remember. So I is E by R, 1 minus e to the power minus RT by L. Very important equation for charging. For discharging, only that 1 minus is not there. It's just e to the power minus RT by L. That's it. Outside it's a constant. Cool. No, you cannot study AC without studying EMI Jagdish. That will be a wrong move. That will be very, very bad. Injurious to health. Do not do that. Okay. Having said this, let's talk about the growth graph. So by the way, this is how it looks like. A battery, maybe some resistance and some inductance. Observe this simulation. Current was not there. As soon as you connect it, slowly the current will start going and it increases. It saturates. Why? Because at time 0, current was 0. And after a long time, the current becomes constant and it becomes I naught. Thank you, Kavita Bacha. Thank you so much, Kavita Jadhav. Alright, so hence, the graph will look exactly like this. Look at that. Current starts from 0, builds up, and becomes constant. Constant after a long time. It is tending to I naught, and that I naught is E by R. You can see that. Alright, so let me just put it over here. So this is E by R, so that is nothing but I naught, obviously. And I just told you about that equation. It was I naught and into, or rather I can just put it as E by R, 1 minus e to the power minus RT by L. Now remember, I just gave the formula for time constant. So the time constant I just told you was nothing but L by R. Substituting time constant and substituting E by R as I naught, you will get I is equal to I naught 1 minus e to the power minus t by tau, the time constant. This equation will particularly be useful if I happen to substitute my time is time constant. If I wait for one time constant, what will this equation become? It will become I naught 1 minus e to the power, t is equal to tau, so it will become e raised to minus 1. Therefore, it will become I naught 1 minus 1 by e. What did I tell you 1 by e was? 1 by e was nothing but, it was nothing but 0.37. 1 minus 0.37 is 0.63. So guys, this tells me that the current builds up to 63% of the maximum current, 63% of I naught after one time constant. I hope this makes sense. Okay, so what has happened? What has happened is that, you know, this time constant gives me an idea how long does it take to build the circuit's current. If this time constant was large, then probably it will take a long time to build this current. But if the time constant was small, then let's say if it was small, then the current will reach very quickly. It will build up very fast. So this tells me how much time it takes to build up 63% of the charge. Remember the standard value, it is L by R. Shall we start doing questions? Thank you, Manjunath. Hi, Chinmay. Good evening, bacha log. Okay, what is the favorite thing I do apart from teaching? Lots of things, bacha. Lots of things. Traveling, watching videos on different random topics, be it general knowledge, be it finance, be it science fantasy, be it physics, or be it movies, yeah. And obviously watching Netflix or Amazon Prime, yeah. And also I like to, yeah, read a lot of stuff, read articles and read blogs and all of that, and probably create some creative videos. That's what I like. Okay, chalo, let's get going. So I have placed the derivation in case you need that. Okay, here is the first question coming up on your screen. Binge watch web series? Yeah, sometimes I do, but not often. Very rare. Only I remember the last series I binge watched was Family Man 2, and before that it was Money Heist. Yeah. Okay, chalo, super ready for problems now. Very good. Is there for time constant for capacitor? Yes, it is. There, Karthishran M. Remember, time constant was RC. Okay, so please check out the Pathfinder series RC circuits. I have discussed that also in detail, including the graphs. Okay, come on, my warriors, figure this out. The question has come up on your screen. Not more than 1 minute to solve this question. Come on, figure this out. What should be the change in the resistance so that, you know, you can make the time constant as 4 into 10 to the power minus 3. Interesting. Oh. Arlav, this chapter is hard, so it's not easy. Only if your previous chapters are clear, like capacitance, current, electricity, and magnetism, and you are decently good with integration, derivatives, and mechanics, only then you can do well in this chapter. Else it will be a big problem. Okay, so please revise current, electricity, capacitors, and magnetism, the entire thing, like the forces and the field and all of that. Only then you will get it. Please do that. Okay, Surya, you can go back a little bit, watch it at 2x and come back to wherever we are. Somebody saying B, somebody saying D, somebody saying also A. Well, the time is up. Alrighty, so many of you are wrong, I guess. So family Badrinath, let's see what we can do to improve your percentile, bacha. Just leave a comment after the session. I'll see what we can do about it. Just let me know in detail what went wrong in physics. I'll help you out. Now, just some time back I told you time constant is L by R, correct? Now think this way. If earlier the time constant was 2 into 10 to the power minus 3 and now it is 4 into 10 to the power minus 3, this time constant has increased 2 times. Now inductance is not allowed to change, only the resistance is allowed to change. So that means That means the resistance has to become how many times? Half times, correct? It has to become half times. Makes sense? So the new resistance will be the old resistance by 2, which is 5 ohm. So earlier it was 10, now it has become 5. So hence it decreases by 5 ohm. That's the answer. Very good, David. Now you got it. Very good, Akshata. Very good. Excelente, Sai Telugu. Yeah, so some of you got it right. Some of you made a mistake, but I hope you understood what mistake you made. So it was just based on the formula. Okay. Chalo, let's get going. Yeah, nice idea, Arnav, I know. But how can you make the live video 2x? For that, I have to talk really fast or I have to talk very slow. Okay, but that's something which I won't do. Next question coming up on your screen now. Let's see if you can do this question in 1 minute. So I'll give you always some time and probably then I'm going to help you with the solution. In this inductive circuit as shown in the figure, the current rises after the switch is on. So it's a charging circuit. When the current is 15 milliamperes, what's the potential difference across the inductor? Let's see how many of you can get this. Very straightforward question. Hint, current electricity. Manish Jadhav, you are too early for this class. This is a 12th standard class. You need a lot of other basic stuff to understand this chapter as well as this concept. So I would advise you, watch the nurture series which I am conducting. I am teaching right now Newton's laws. Okay, so watch the previous lectures in case you have doubts in that, and watch our nurture series lectures for 11th standard. Okay. Okay, Srivatsan. Okay, duly noted. I'll think about it, Bacha, whether we can do something for NDA. But try. As of now, there are no plans, but let's see if we can do something. Okay. So, Kirtika, all the formulas of the end of the chapter, in fact, the PDF is available for you guys to download. So, all the PDFs you can download and all the formulas will be there with you. Okay, number 1. Number 2, if you want formulas, there is a special formula session which I conducted for 2.5 hours. You can watch that formula session. So it's a beautiful session which talks about all the formulas from most of the chapters. That's also something which you can watch. So download the PDF or watch that session. Both will work. Okay, cool. Now, let's get going and see how to solve this question. Many of you are saying C. Interesting. Oops. Okay, let's see what should be the answer. First of all, when you close the switch, the current will start flowing, and that current was 15 milliampere. Same current will flow here. Same current will flow here. Okay. Now, if you apply KVL, look at this. If you apply KVL starting from here and going across this, so Kirchhoff's voltage law, starting from this point, I will get plus 240, okay, minus IR, minus I into R, okay, minus the voltage drop across the inductor is 0, coming back to the same point. Therefore, I am going to get 240 minus, what is I? 15 milli, that is 10 to the power minus 3. Resistance is 4 into 10 to the power 3. Shift that guy over there, it will become VL. Therefore, VL will become 240 minus 10 to the power 3, 10 to the power minus 3 goes 15 4s 60, which is going to give me how much? It's going to give me 180 volts. That's the answer. Read the question carefully. Potential difference across inductor was asked, not across the entire circuit. So hence, yeah, C is not, many of you answered C. Very good, very good, very good. Excellent. Very good. Very good. Very good. I'm super proud, super duper proud of my warriors. Very good. Excellent, guys. Let's see the next question if we can get this. Come on, my warriors. Let's do this. No, Thevenin's theorem, Chaitanya ji, is not a part of JEE. It's not needed. Some people tease that just to show off. It's just to gain some popularity, but it is not needed. You will study that in the 2nd or 3rd year of your electronics engineering. Okay, most likely 2nd year, you will see that. All right. So Jagdish will be coming up with the advanced series very soon. Don't worry, bacha. Let the mains get over. An EMF is applied to a circuit. 5 Henry is the inductance, 10 ohm resistance. What is the ratio of the current after a long time and at t is 1 second? Just take the ratio. Hello Akshita, welcome aboard. Ria will let you know, bacha. Right now, this week, though, most likely no. I'll see if I can make it till Saturday. I'll see, not assuring anything, but most likely next week, or maybe a 20% chance on Saturday. I'll just try, okay? Because a lot of things are going on right now. Already I'm packed with the sessions in the regular sessions on our Vedantu, plus, you know, managing the department and also on YouTube. Okay. Hello Akshaya, welcome aboard. Some of you are saying D, some of you are saying B. Let's see science gaming if it is B or D. Interesting, interesting, interesting. Glad to know that Akshita, keep following us. And yes guys, if you are loving all our sessions, please smash the like button now. It means a lot. It's a small Guru Dakshina from your side to me. Okay. Sai Telugu saying B. Hi Harini. Okay, chalo. Let's do this question. First of all, an EMF of 15 volt is applied in a circuit containing this much. So this is a charging circuit. Okay, so this is a charging circuit, and we know that in a charging circuit, the current will be, you know, I naught e to the power minus, it is a charging, 1 minus e to the power minus RT by L. So that's how the current will improve in a charging circuit. Now, there are two times, one is infinite time and one is 1 second. So the ratio that I have been asked to find is I infinity by I1. So I infinity will be I naught 1 minus e to the power minus, this will become infinite, okay, upon this will become I naught 1 minus e to the power minus, put the value of time as 1. So minus, R by L, that's it. So what will happen next? I naught will cancel. I hope you can see that. So this will become 1 minus e to the power minus infinity is 1 by infinity. It's a big number. Think about it. E raised to infinity is a very big number, but that will come below because of that negative power. This divided by 1 minus e to the power R by L, e to the power minus R by L. What is R? 10. What is L? 5. So e raised to minus R, which is 10, by L, which is 5. So this will become 1 by infinity is 0. So this will just become 1. Okay, 1 by infinity is 0. Keep this in mind. Okay. And here you will get 1 minus 10 by 5 is 2. So e raised to minus 2 is 1 by e square. Obviously you have to take LCM. So it will be 1 by e square minus 1 by e square, which will be e square upon e square minus 1. Where is it? I think it's option B. It's not half, it's B. It's raised to 2. Very good. Very good Kartishran, very good Jayashri, very good Lone Wolf, Akshaya, very good. Kavita, I'll have my dinner after the session every day. Okay, that's my timing fixed. Very good Chaitanya. Hello Rakesh, welcome aboard. Alright, so that's the correct answer. That's easy if you know the formulas and do the substitution correctly and cancel things, basic algebra, and you will get it. Okay, now comes an interesting question. And let's solve this together. Okay, now let's do this. Good evening, Bezachi. Okay, hi Ashoka. Hello, Akash. Welcome aboard. What is the difference between the 11th standard JEE portion and 12th standard JEE portion? Very interesting question, Krutugao. So the 11th standard portion and the 12th standard portion, the difference is that the 11th standard portion has to be studied from the 11th standard textbook and the 12th standard portion has to be studied from the 12th standard textbook. The 12th standard portion has to be studied by the 12th standard students and the 11th standard portion has to be studied by the 11th standard students. So that's the difference. Okay. I didn't know what exactly was the question. Was it the same thing or was it something else? Okay. Now, going to this question, observe this. There is an inductor, there are two resistors, there is a switch and it is closed. Find the current immediately after you close it and after a long time. That's the question. So, something which I told you should remind you right now, especially in case of a charging LR circuit. Remember what I told you. When it is just connected, an inductor will act like a what did I say? It acts like an open switch. So it acts like an open switch. It's not a part of the circuit. So just forget the inductor. Just forget it. Because in fact, the current in this branch will be zero. There will be no current in this branch. Okay, initially. But there will be current in this branch for sure. And if you just mentally forget this part, just hide this part mentally. Only this much circuit is there. So guys, what will be the current in this circuit? Quickly, EMF is 12, resistance is 2 ohm. So what will be the current initially? That will be 12 by 2. So 12 by 2, that is 6 amperes. Got it? That's initially. I'm coming to LC oscillations after some time. Okay. Next up, after long time, what will happen? After a long time, what will happen? An inductor behaves like a wire. Didn't I tell you about this? After a long time in a LR charging circuit, it behaves like a wire. So think this inductor is not there, but there is just a wire. So this circuit will now become like two resistors in parallel, nothing more. That's it. These are two resistors. So resistors in parallel. So what will be the equivalent resistance? These are two resistors of 2 ohm and 2 ohm each. So it will be 1 ohm. So this current I will be E. What is the value of EMF? It is 12, I guess, divided by 1, which is 12 amperes. So 12 amperes current will flow through the battery, but that current will get divided in both of them as 6 amperes and 6 amperes because the resistors are equal. That's why. So that's the final answer. Understood? No, it is not 6 and 12, it's 6 and 6 only. Okay, yeah, 6, 6 and 12, that's how it is. Initially it was 6, 0 and 6. That's how it works. Understood or clear? So remember this trick. After a long time, inductor is like a wire in charging circuits, and just when you connect it, it is like an open switch. That's the logic to be used. Okay, so yes, we got it 6 amperes and 0 amperes in both the branches, and 6 and 6 amperes after a long time. Cool. Hello Archana Bacha, welcome aboard. Now the same question, but there is a different thing which has been asked. The only thing which has differed is that the switch is closed for a long time and then opened. That means it is a discharging circuit. It is a discharging circuit. Now think, when you just open it, there was already some current flowing in it. What was that current? I just figured it out some time back. Remember, it was 12 amperes and here it was 6 amperes in the previous question. Just the previous slide. This was the current which was already flowing in the circuit. Now the moment you open the switch, understand what's going to happen is that, see, there is inductor in this branch. What does inductor do? Does inductor like any changes of current? Think about it. Does inductor like any changes of current? Yes or no? So remember, inductor resists changes in current. It does not like it. It does not like any kind of change in current. It will oppose it. So this inductor will be like, okay, the battery vanished, the current will eventually become 0, but it will not let it become 0 instantly because this branch has some inductance. So at time 0, you will see the current will still remain 6 amperes, but there is no inductor in this branch. So this current will instantly die to 0 amperes. So that is the answer for time 0. So just opened just opened at t is equal to 0. Inductor will resist, so it will maintain the current. But this branch, there is no inductor. So first say 0 instantly. There is no opposition. Correcto. Is that clear? Now, after a long time, this is simple. After a long time, basically the current decays completely. The current decays completely. So if the current decays completely, what will happen, guys? You keep the circuit open, there is nothing to supply energy. Eventually the current will become 0 ampere, 0 ampere, and obviously 0 ampere. There will be nothing flowing after a long time. That was very obvious. Okay? No, this inductor will eventually lose the current because this is LR circuit. It will lose the current eventually because there is nothing to power it. This battery has been disconnected from this main circuit. So the energy will be lost. Eventually the 0, 0, 0 will be happening. Okay? Cool. So Vicky, in the next 2 months, expect the syllabus to be done, which will be much before even your term 1 board examinations. Isn't that interesting? Don't you want your complete JEE syllabus to be over even before your term 1 examinations? Yes or no? Cool? Yes. So that's the answer. Beautiful question, guys. Okay. Well, I think this answer should have been 6. This had to be 0. So I'll just change it over here. Okay, cool. Yeah. Great. So that's the answer. Now, let's go to LC oscillation. But before that, if you want to practice more problems, you need to practice it from the Tattva book. This is the Vedantu material which we courier to you at your doorstep, at your address. This has all kinds of problems that you can think of, and it looks something like this. Okay, it looks something like this. It has the theory summary, it has the formulas, the diagrams, the graphs, the concepts, definitions, and the shortcuts, along with solved examples, along with exercise 1 for simple conceptual direct application concepts, and then exercise 2 with previous year main questions, and then you have exercise 3 for advanced level problems, and then exercise 4 for previous year advanced question. So gradual increase of the problems. So this is what you get in the Vedantu Pro if you are a part of it, and you'll also get the soft copy. So by the way, there is also TargetJEE NEET campaign which is running right from 19th of August. Okay, so if you are in 11th, 12th, or even passing out student, please register for the camp, which is there right in the description box. There is a link. Please register for free because you are going to get amazing prizes worth 2 lakh rupees up to, and there is a test which will help you analyze where you stand and what's your performance like. And also there will be lots of free live classes and guaranteed scholarships as well. So all of this, if you just register, the link is there in the description box, and more about it will be coming up soon. Okay, whatever information you need, you will get it over there, but if you want some more information, you will see it over there. You just fill up all your details. Okay, now let's talk about LC oscillation. Jatin, there is no PDF for Tattva. 1 second. Yeah, so Jatin, the PDF for Tattva is not available in the market, Vacha. There is, it can be only seen through your account, okay, not otherwise. If you only want to buy Tattva, it's not possible, Arnav. The only way is you register for the entire 12 months course, or basically the entire, year. Only then you will get the Tattva module. There is no other way. Yes, you need to pay the full fees, or even you can pay monthly fees in EMI option. So every month you pay 3,000. So you'll get the long-term batch, you'll get the doubt solving, you'll get the test series, you'll get the revision lectures, you'll get BitSat coaching, you'll get KVPI coaching, you'll get boards coaching, everything along with Tattva, and the discussion sessions and the test series and the discussions and all of that. So that's how it works. You can pay monthly also. Cool. Oh, Vijay Kumar, क्या बात है? मुझे हिंदी थोड़ा थोड़ा मालूम. क्या बात है? आप कैसा हो? मैं एकदम बढ़िया हूँ. तुम भी बढ़िया होंगे शायद, और तुम्हारा हिंदी बहुत अच्छा है. 1 नंबर. चलो, LC oscillation. What is LC oscillation? In LC oscillation, see, if you just connect inductor and resistor, we just saw, that the energy stored in the inductor slowly decays across the resistor unless you power it up by a battery and the current grows slowly in the inductor and reaches a steady value. So the resistor is like an evil guy which always sucks away the energy. So what if we take away the resistor and just keep a capacitor instead of that? That becomes an LC oscillating circuit. Why oscillating? I'll come to it. But the point that I want to make over here is that inductor and capacitor both are energy storing devices. Both are conservative devices which store energy without deceiving you. Resistor is an evil guy. The moment you pass current, it will lose it in the form of heat, I squared R losses. But capacitor will store in electrical energy. Inductor will store in magnetical energy. Remember the formulas? Half Q square by C was the formula for energy for a capacitor, and half Li square is the formula for energy in an inductor. Hence, think about it. If I have just inductor and a capacitor, there is no way the energy can go out of the system. So the total energy will be conserved because all the fields involved are conservative in nature, magnetic and electric. Hence, the energy is continuously constant in the circuit. But if, for example, the capacitor is charged, capacitor has energy, inductor has no energy, that means what will happen is that all the energy from the capacitor will flow to the inductor. And after some time, the capacitor will get discharged, the inductor will get charged. Inductor will be like, okay, take it back. Again, the energy will flow from inductor to the capacitor. Now the inductor will lose energy, capacitor will gain energy, and capacitor will be like, okay, I can take it back. So they both keep juggling that energy back and forth among themselves. And that's why in this juggling, you will see the circuit becomes oscillating in nature. So they keep juggling that energy between electric and magnetic, or capacitance and inductor. So that's why it is called as an LC oscillation. There will be no loss in the heat because there is no resistance. Are you clear with this? Think about it. Okay? Okay. So yes, Jatin, I know there will be some channels, but that will be illegal to share any kind of Vedantu material because there is a lot of hard work. There is a big team sitting behind them. Just think about it, Jatin, how much it will pain us. Like we are paying the salaries of I don't know how many people out there just to make that book. And I know a lot of people who probably illegally download not just books but also, you know, songs. Guys, please stop this piracy. It goes there is a lot of hard work which goes behind any kind of work that you see on the internet or anywhere else, be it movies, be it songs, be it books, or any kind of art. We just probably would have just downloaded that song or that movie for free. So, you know, it used to happen when probably when we were young, we never used to understand, you know, what are the repercussions. So I have reached a stage where I do not download anything from torrents. I do not download anything from illegal ways where we only use, you know, proper resources to actually download a movie or to watch a movie or to listen to any songs. Pay for it, guys. I mean, there is a lot of hard work which the artists or, you know, they have to support an entire crew, or even when these books are made, there is a big team who are feeding their families, who are working hard day and night just so that this content has been made, correct? So that is not good. Yeah, cool. Now let's get going. Let's start solving the equation for this. Okay, you can see over here the capacitor gets charged, the current flows to the inductor, inductor gets energy, and again the inductor leaves back that energy over here. You can see that, you know, the energy flows back and forth. Now let's write this down. At any instant, okay, can I say the total energy will be energy in the inductor plus energy in the capacitor? Obviously. Maybe there is current I, maybe there is, I don't know, there is minus Q over here, there is plus Q over here. So there is current flowing in the circuit, there is inductor's energy and capacitor's energy. So that's the total energy. So what will the total energy be? It will be half L I square plus half Q square by C. Differentiate both sides. What am I doing? Differentiate both sides with respect to time. With respect to time. Let's see what happens. dE by dt, the rate of change of energy, will be half L is a constant. I square's derivative cannot be taken with respect to time, so I'll use chain rule into di by dt. The reason why I did that, because this is I, this is time, so I have to use chain rule, plus half C, okay, and derivative of q square cannot be taken with respect to time, so use chain rule again over here. Make sense? Now think about it. Hello Zayad, don't spam bacha. Yes, welcome back. Now Tattva, yes, it's almost like 70% enough, but you need to solve more, like the assignments, mock tests and all the recommended books which are given by the teacher, and that is usually H.C. Verma and Irodo, nothing more than that. Okay, now dE by dt will be 0. Why is it 0? Because remember, this energy will always be constant. Basically, it is conserved. This energy will remain conserved because there is no resistance in the circuit. Correct? So that's why the rate of change of energy, constant's derivative will be 0. This is half L and I square's derivative will be 2I. dI by dt, okay, let's see what to do with that. Just let's keep it as di by dt, plus this will become half C and this q square's derivative will become 2q and this dq by dt will become I. Now lot of things will get cancelled. Observe this. 2, 2, 2, 2. I and I from here will cancel. So I am left with 0 is equal to L di by dt plus q by C. Fair enough till this point? Everybody fine? You can solve it without derivative via different methods. Again, that is KVL, but probably you might need integration there. So I find this method convenient because there is not much of sign convention involved over here. This is energy method for finding the SHM equation. Okay, now I'm erasing this because I no longer need it. Okay, I'm just erasing this part. Okay, observe this. This can be written now as L di by dt. Current itself is derivative of charge. So can I not say this is second derivative of charge? Correct, this is second derivative of charge, di by dt, where I itself is dq by dt. So it's d square q by dt square plus 1 by C into q. This will be equal to 0. That's what I got. Now this reminds me of the SHM equation, which looks something like this. MA, which is mx, second derivative, so d square x by dt square plus kx is equal to 0. This was equation for, SHM, spring mass system. If you remember, this equation is exactly similar to that, where you have x is equal to q, correct? Instead of x you have q, instead of mass you have L, and instead of K you have 1 by C. So these are the replacements. These are the replacements from mechanics to electromagnetism. In mechanics, position is equivalent to charge in electromagnetism. Mass in mechanics is similar to inductor, which is inertia. Spring constant is similar to 1 by capacitance. Keep this in mind. Now you know what will be omega. Remember, omega was here root k by m, correct? It was root k by m. So what is k? K is 1 by C. So C will come below. What is m? M is L. So it will be 1 by root LC. So that is the first equation that you should be thinking about. You can also write time period, which is 2 pi under root. By the way, remember, time period was nothing but 2 pi under root m by k. So what is m? M is L. What is k? 1 by C. So 2 pi root LC. So either ways, if you know omega, you can get T. If you know T, you can get omega. Isn't it interesting, guys? Yes. So Neeraj, it's not possible, bacha. If you want 5 days classes, you have to join the Pro subscription. Okay. 2 days to 3 days per subject is fine. All right, because we have commitments for 11th, 12th and the passing out students. Probably when the 12th standard students pass out, maybe we can increase the number of lectures, but it's good enough. So if you want the proper systematic flow, you should be a part of the regular series where you get dedicated attention, you have tattva discussions and all of that. Okay, very good. Now, having said this, I can also write the charge as a function of time by again comparing it with your linear mechanics. Okay, I'll just erase this now. I no longer need this. Okay, I'll just erase this now. Remember, x was a sine omega t plus phi. Remember that? This was the equation of SHM. But in LC oscillation, instead of x, you will have q. Instead of a, you will have maximum q, which is q max, maximum charge. And you will have sine, and that omega t, same omega t plus phi. That's what you're going to get. So this is charge as a function of time, guys. So you can see clearly the charges are oscillating like a simple harmonic motion, as simple as that. Okay, no problem, Neeraj. You can start studying from here. And remember one thing, that even if you have one subject for 2 days or whatever, 1 day or 3 days, it is distributed, so you need time to actually solve the problems from the books, bacha. So a lot of practice is also needed, and if you take 5 lectures in a week, what will happen? The syllabus will get over really fast, and then what will we do? And plus you have to also grasp, it takes some time to actually sit and solve, make your notes, write down the formulas, revise, solve the basic, mains, advanced problems. So that's why you need that time. Okay, lastly, current which will be dq by dt. Take the derivative, guys. You will see it will be q max. Derivative of sine, which will be cos omega t plus phi, and that omega will come outside. So that's what current would be. Clear, everyone? So that's how you compare SHM in mechanics and electromagnetism. Very, very similar. So I have given you all the equations and this beautiful simulation. Probably you can play it again and again. Observe it. A simple harmonic motion on the left hand side, and on the right hand side you have energy oscillating in a LC circuit, which is electrical circuit. You can see the energy goes between capacitor and inductor back and forth. Here in a simple harmonic motion in mechanics, it goes from kinetic energy to potential energy. So that's what happens. It's very, very similar. You can see that. Observe this. Okay. By the way, this will be there as a recording as well as in the PDF. So like I said, omega is 1 by root over LC. Total energy is energy of inductor plus energy of capacitor. And the charges vary and oscillate periodically as a simple harmonic function. Charge is q sine omega t plus phi, and current is maximum current sine omega t plus phi. Let's go to the first question coming up on your screen. Oh, no problem, PL. Please take rest. You can watch the lecture later on, bacha. Thank you, Sasidharan, for all the love. Glad, Arnav, it's helping you. Hi, Rajaram. Okay. In which devices? Oh, by the way, start solving the question, guys. Waiting for your answers within 1 minute. Meanwhile, I'll start answering the queries that you guys are posting. Thank you, Kavita Jadhav. So in which electrical devices inductors are used? They are, basically any transmitting or receiving antennas have inductors. Chokes, okay, these are also electrical devices. They also are nothing but inductors. Also, you might have seen some devices where the bulb glows slowly. It takes some time to glow. So that again is nothing but inductor. You might have seen fan regulators to vary the speed. They also have inductors inside them. So in AC also, there are a lot of applications to shift the phase and bring two different phases aligned to each other. So again, you can use inductors as well as capacitors. So a lot of applications. Okay. Chalo. Hello, Pushpendra Verma. A lot of you are saying B. Are 8 hours daily online classes fruitful? Jatin, you don't need 8 hours of online classes. 4 to 5 is decent. 4 to maximum 6, not more than 6. Okay. Okay. Well, the correct answer is B, guys, and you should know this by now. Omega is 1 over root LC. As per the question, L has increased how many times? 2 times. C has increased how many times? 4 times. So this ratio has become 2 into 4 times, which is 1 by root 8 times, which is 1 by 2 root 2 times. So the answer is omega by 2 root 2. That's the answer. B. Got it? Very simple. Just ratio and proportionality. Next question coming up on your screen now. Deepa Dodami, you are current. Very good. I just hope you don't encounter any resistance. Okay, chalo. Let's see the next question coming up on your screen. Figure this question out. Conceptual level question. Come on, my warriors, figure this out. Come on, come on, come on, come on. Figure this out. The LC circuit shown in the figure, the current is in the direction as shown. So, is the charge increasing or decreasing? Is the current increasing or decreasing? Observe this carefully. Let's see. Look at the current's direction. Current is the flow of positive charges. So, basically, equivalent positive charges. So, positive charges are going here. Makes sense? So, the positive charges are moving this way, taking the current like this. So this negative will become more negative or less negative? Obviously it will become less negative. This will become less negative. That means even this, because these positive charges are coming from which side? This side. The positive charges have been taken like that and put over here. So this will become less positive. That means the charge, what is happening to the charge on capacitor is decreasing. Makes sense? The charge on the capacitor is decreasing. Cool. Now, if the charge on the capacitor is decreasing, think about it. Therefore, energy in the capacitor is also decreasing. Correct? But we all know that the total energy is energy in the capacitor plus energy in the inductor. If the energy in the capacitor is decreasing, to keep the total energy constant, shouldn't the energy in the inductor increase? To keep the total energy conserved, if capacitor's energy decreases, inductor's energy should increase. And what is the energy of an inductor? The energy stored in an inductor is half Li square. Half Li square. So if the energy in the inductor increases, that means this current should increase. Understood? Hence, the charge is decreasing and current is increasing, which is option C. Straightforward, logical, beautiful conceptual question. Yes, Nupur Talwar, I'll finish the KVPY, I'll finish the 12th standard syllabus much before your KVPY SX. Definitely, bacha. Okay, I've told you, right? I'll be finishing most of it. I'll be finishing it even before your term 1 examination of boards. So if you want that, you need to support, you need to bring a lot of your friends out here. I should feel that you guys are interested. If I feel that you guys are not interested, then maybe I'll shift to some other series. So yes, please get your friends along. Make sure you support this channel. Make sure you spread the word. Make sure all your school students, your batchmates are attending this channel. Spread it. Make it like fire. Alright, let's go to the last question coming up on your screen and then I'll show you the homework questions. Interesting question. Come on, my warriors. Very good, Zayad. You said it first. Now, here you have inductor given, capacitance given, initial charge also given. Obviously, it will oscillate. Question is find charge and current as a function of time. Let's find one thing at a time. Omega. What will be omega? Let's just try to figure this out. So, what will be omega? Omega is 1 by root over LC. So, it will be 1 by root over L is 1 millihenry. So 10 to the power minus 3. Capacitance, that's 4 millihenry. So 4 into 10 to the power minus 3. Now root of 4 is 2. 10 to the power minus 3, 10 to the power minus 3's root is 10 to the power minus 3. Both will come in the denominator. So it will become 10 to the power 3 by 2. Okay, so that's basically 1000 or 10 to the power, just leave it like that. Okay, radians per second. So that is omega. Cool. Next up, the charge on the capacitor is 5 millicoulomb. That means only capacitor right now has plus 5 millicoulomb. Okay, and that's it. Oops. And you just connect the inductor. What will be the current in the circuit at that time? The current in that circuit will be 0. The energy in the inductor will also be 0. Capacitor is fully charged, it has energy, there is no current yet. So can I say this is the maximum charge? The initial charge will be the maximum charge. Think about it. So the charge starts from plus 5, it goes down, it decays, the energy goes into inductor. Then again you will see the energy will come back, again this will become plus 5, again the energy will go back to the inductor, again the charge will become 0. So it will keep alternating, fluctuating between both of them. So can I say the Q max is itself 5 millicoulomb? Fair enough. Great. Now at t is equal to 0, Q is also 5 millicoulomb. At time 0, it's given that initial charge is 5 millicoulomb. So using this equation, Q is equal to Q max sine omega t plus phi. What will I get? Observe. Q is 5. Q max is also 5 sine omega t, time is 0 plus 5. Therefore, sine of phi will be 5 by 5, which is 1. Therefore, phi is 90 degrees. This is initial. Remember, in SHM we have talked about this. Initial phase angle. That's what I got. Cool. Now I have every term that I need to make or phrase this equation. Therefore, Q will be equal to Q max, that's 5, sine omega is 10 to the power 3 by 2 into t plus pi by 2, which I can also write it as cos. I can also write it as cos. Everybody getting it? Everyone understanding? I can also write it as cos. By the way, this is millicoulomb. So this will be nothing but 5 cos 10 to the power 3 by 2. Okay, millicoulomb. That is charge. So that's the function of time. Now the only thing left is current. That is also simple. I will probably erase this part. I don't need it anymore. Now the current is dq by dt. So it is derivative of this guy. So that is 5 cos, 10 to the power 3t by 2. Okay, millicoulomb. That is milli. Okay. So this will become, what else we get? Yeah. So 5 cos's derivative will be minus sine. So minus sine 10 to the power 3 t by 2 milli, and this number should come outside because its sine of kx's derivative will be cos kx. So my k will come outside. Cos kx's derivative will be minus sine kx with that k outside. So this constant should be outside. So into 10 to the power 3 by 2. Now 5 by 2 is 2.5. 10 to the power 3 and milli is 10 to the power minus 3. That will vanish. So you will have sine 10 to the power 3t by 2. This will be in amperes. That's current. So these are the two answers that you should be looking forward to. Okay, so that's how you solve the questions. Okay, it's like pure mathematics, nothing else, just substitution, but you will get it. Okay, you practice this again and again. Understand each and every term again and again. It's direct repetition of simple harmonic motion of 11th standard. Okay, nothing else. Okay, so those are the answers. Now I'm expecting you guys to post the answers for whatever you understood. Even if you're watching it in a replay mode, please post the answers in the comment section. Drop a comment. This is your first question. Second question again on this, okay, on inductors charging and discharging. And lastly, LC oscillation. That's the third question which you need to solve. Now, those of you who were asking, sir, can I get Tattva module? Sir, I want to study under you. Sir, where can I get my doubts solved? Is there a KVPY batch? Everything is there. In fact, we are giving you a promise that if you do not improve, then we'll refund back your money. So that's VIP, Vedantu Improvement Promise. We say that if you're attending our classes regularly, if you're studying with us, and when you join us, we are going to assess you, and by the time the course is over, you should have improved, else the money is returned back. No other coaching institute in this country does that. And the reason why we are so confident is because of our results, because of our teaching, because of our books, because of our test series, because of our assignments, because of the infrastructure that we are capable of giving you guys. Now remember, the batches are in English as well as Hindi. Both options are available. So once you join the Pro subscription, you will get a call from our team whether you want to join English batch or a Hindi batch. So most likely you're going to choose the English batch. You can also join all my micro courses for free of cost. KVPY batch free of cost. But there are some students who will be like, sir, I just want KVPY batch. No problems. There you go. Just watch the video and go below in the description box. You will see that there are a lot of links out here. Okay, you will see the KVPY SX crash course for 4,000 rupees. You can click on this link, enter your details and join only the KVPY batch for the SX examination. But if you want this as a part of your curriculum, well, all you need to do is go to the Vedantu Pro link, and that's where you will get all the courses, short courses, other courses, revision till the last exam of 2022. That is JEE Advanced. Okay, so this is a JEE Mains Plus Advanced batch. You will see 3 versions, Light, Classic and Plus. Whatever I told you, everything is there. Now, only if you want doubt solving on mobile app, then you go for the Classic version. And if you want somebody to mentor you personally, then you go for the Plus version. The only difference in the price is marginal. So you can see the entire 1-year batch price is 36,000 rupees for the Light version. And if you buy it monthly, it's around 3,000 on EMI, or even if you pay it monthly. Okay, you can buy it for a month, try it for a month. It's hardly 3,000 rupees. And if you are interested in the doubt solving or personal mentorship, please check out the other links as well. You have to use the coupon code SHHPRO. Only then I can help you if there is a problem or if you need some assistance when you join the course. Okay, so apart from the discount that you get. So go ahead guys, check it out. I would be very much interested to see you in the Pro subscription. And I'm pretty sure the combination of YouTube plus the Pro subscription will help you ace in the upcoming JEE examination. Thank you guys for tuning in. Bye Zayed. Bye Kavita. Yes, I know Rudeep. Alright, bye Uma. Take care and have fun. See you Deepa. Bye bye. Bye bye. Take care. And this was your captain. And by the way, do not forget to smash the like button and hit the subscribe button down there. The PDF of today's session will be there in the Telegram channel and also in the description box after some time. Okay, I'll be seeing you guys for the Menti quiz on the entire chapter very soon. 11th standard classes tomorrow. Every day you will find me almost at 7:30 p.m. So this was your Capto Shreyas. Hasta la vista. Good night. Take care.